Hi all, this video will cover the basic problems in Laplace transform. We will cover two problems. The first problem is x of t equal to e power minus at u of t. So I wrote the formula for finding the Laplace transform of x of t, which is x of s. X of s is equal to integral minus infinity to plus infinity x of t e power minus st dt. Now I am just replacing the value of x of t in this. So the x of t can be replaced with u of t e power minus at, or else e power minus at u of t. So e power minus at u of t, and we are having e power minus st dt. So you know u of t equal to 1, u of t equal to 1. For t is greater than or equal to 0, and 0 if t is lesser than 0. So I can change the limit as 0 to infinity because this is the useful limit. So for which u of t takes the value equal to 1. For the range minus infinity to 0, the value of u of t equal to 0. So I am just leaving the limit because that results nothing but 0. So here e power minus at, instead of u of t I just replacing with 1, and we having e power minus st dt. And combining the exponential terms, the next step will be 0 to infinity, and taking e term common and taking minus t common in the power, this term becomes minus s plus a into t dt. Why I am taking minus t common means, since we are having infinity in the limit, if you take minus t as common, then only you will get a finite value if you substitute the upper and lower limits. So in the next step we are integrating the exponential term. As you know, the integration of e power ax is equal to e power ax divided by x. So in this case we are integrating with respect to t. So the result will be e power minus s plus a into t divided by the coefficient of t, so which is nothing but minus s plus a. So the upper and lower limits are infinity and 0. So we need to consider about the value of s. In this case we will get a finite value if the term within the bracket is positive. That is, if s plus a is greater than 0, then only this term is positive and the product of this term and t will be positive. And if you substitute infinity for t, then you will get a finite value for this exponential term. If this term is negative, then negative into negative will be positive. If you substitute infinity, then that will result a infinite value. So we will consider this case. So s plus a is greater than 0. So the value of s need to be greater than minus a to make s plus a as a positive value. Okay. So since you know s is equal to sigma plus j omega, s is a complex number, so which is nothing but sigma plus j omega, where sigma is nothing but the real part and omega is imaginary part. Here j omega, if you put j omega, we will consider a as a real number. So in this case we need to bother only about the sigma value. Here if you consider only about the sigma value is nothing but the real part of s. So the condition for making this term as a finite value is nothing but real part of s need to be greater than minus a. So usually this thing we will consider as region of convergence, ROC. Okay, so considering this, just note down this. So just apply the upper and lower limits. If you are applying the upper and lower limits, then the equation becomes. So I am just taking the denominator outside. So I am just having a minus s plus a. Okay, now I am applying the upper and lower limits. Applying the upper limit, I will get e power minus infinity, minus applying the lower limit, I will get e power 0. So this can be written as minus 1 by s plus a, and in this case e power minus infinity equal to 0, minus e power 0 equal to 1. So this value will be 1 by s plus c. Okay, so the Laplace transform of x of t equal to e power minus at u of t is nothing but 1 by s plus a with ROC. We have to mention the ROC whenever you are finding the Laplace transform of any function or any signal x of t. Okay, because this is so important. So real part of s is greater than minus c. Okay, so we will see one more problem in the same category. So in this case, we will consider the next one. Here we are taking the thing x of t. In the previous case, we considered the causal signal. In this case, we are considering the anti-causal signal. X of t equal to e power minus at u of minus t. Okay, so the thing is, here instead of u of t we are having u of minus t. Consider this as a second one. The previous is nothing but the first problem. The same formula for Laplace transform. X of s is equal to integral minus infinity to plus infinity x of t e power minus st . So just replacing the value of x of t with e power minus at u of minus t, and we are having other terms in the Laplace transform formula. So mentioning the upper and lower limit. Okay, you know u of minus t is nothing but the anti-causal version of the step signal. So which is equal to 1 when t is lesser than or equal to 0, and 0 when t is greater than 0. Okay, so here the useful range is nothing but minus infinity to 0. Okay, why? Because the value of u of minus t equal to 0 when t is greater than 0. So we are not bothering about the range 0 to infinity. We are only considering the range minus infinity to 0. So in this case, in this range, e power minus at and the value of u of minus t can be considered as 1, and we are having e power minus st dt. So this is equal to minus infinity to 0. We are just merging the exponential terms, and here we are just keeping t common. Instead of minus t as like the previous case, here we are taking the t common. So if you are taking t common, we will have minus s minus a into t. you just cross check with the previous step, you will get like this. Okay, so after this we are doing the integration. So you know, integration of e power ax is equal to e power ax divided by x. In this case, e power minus s minus a into t divided by minus s minus a, and we know the upper limit is 0 and the lower limit is minus infinity. Okay, so this term minus s minus a need to be a positive value so that the product will be positive. If you apply t as negative value, negative infinity, then you will get some finite value. Okay, the objective is to make this term need to be finite if we apply the upper and lower limits. Okay, so this is the condition, minus s minus a need to be greater than 0. Okay, in this case we just move this minus a to the right hand side, a. If you move the negative sign from the left hand side to the right hand side, then s need to be changed lesser than minus a. Okay, so if you are changing the sign, the greater symbol will be changed to lesser symbol. Okay, so you know the value of s is nothing but sigma plus j omega, and the a is nothing but a real value, so this can be specified as real part of s is lesser than minus a. So this portion or this term we will call it as ROC. So let us consider with this ROC we are solving this problem. So just apply the upper limit. Before that you take the term minus s minus a common. After that apply the upper and lower limits. So applying the upper limit, you will get e power 0 minus applying the lower limit. Here we assume this value is a positive. If t is equal to minus infinity, e power minus infinity equal to 0. So this can be written as 1 by taking minus common s plus a, and e power 0 equal to 1 minus 0. So this is equal to minus 1 by s plus a. Whenever you are finding the Laplace transform of a function or signal, you have to mention the ROC. For this case, the ROC is nothing but real part of s is lesser than minus a. Let us consider the interesting part of Laplace transform. First we will see the Laplace transform obtained for the first signal, e power minus at u of t, and the Laplace transform is 1 by s plus c. If you find the Laplace transform of minus e power minus at u of minus t, then also you will get the same result, 1 by s plus a. Okay, to obtain this just multiply both sides by minus. Since we calculated the Laplace transform of e power minus at u of minus t, it is easy to obtain the Laplace transform for the previously told signal. So how both are differing from each other? The thing is ROC. For this case, ROC is real part of S is greater than minus E. And for this case, ROC is real part of S is lesser than minus E. These results are very helpful in finding the inverse Laplace transform. The same ROC is applicable for this too. We will see few problems. Let us consider the problem A. Here we are having x of t equal to e power minus 3t u of t. So if they are asking this kind of problems in 2 mark, you can just apply the formula and you can deduce the result. Here for this problem, the value of x of s is nothing but 1 by s plus 3. Whenever you are mentioning the Laplace transform, you have to mention the ROC. For this case, ROC is real part of s is greater than minus 3. And see the second one, B problem. X of t equal to e power minus 2t u of t. So for this problem, the x of s will be 1 by s plus 2. And the ROC is real part of s is greater than minus 2. If you are having the other version, x of t equal to minus e power minus 2t u of minus t, then x of s will be 1 by s plus 2 only, and the ROC will differ. So ROC will be real part of s is lesser than minus 2. So let us see another problem. In this problem, x of t is a sum of two signals. So x of t equal to e power minus 3t u of t minus e power minus 2t u of minus t. Okay, for this problem, you know the x of s for the first term, which is 1 by s plus 3, and you know the x of s for the second term, which is nothing but the Laplace transform of e minus e power minus 2t u of minus t 1 by s plus 2. Okay, when we are having two terms, we have to consider the ROC. Here one ROC is real part of s is greater than minus 3, and the another ROC is real part of s is lesser than minus 2. So combining the ROC can be obtained by merging the two ROC. So real part of s is greater than minus 3 and lesser than minus 2. If you mention the ROC in this plane, it will be like this. So the y-axis is imaginary axis j omega, and the x-axis is the real axis sigma, and here this is the origin 0 comma 0, here it is -1, -2, and here it is -3. Okay, so according to this ROC, real part of s is greater than -3 and lesser than -2. So this will be like this. So usually the ROC does not contain any pole. So this region will not contain the poles -3 and -2. So this is the ROC for the problem C. Sorry, problem D. Thank you.